Mullet over day 3. Chief historians in stock. You're welcome to check the warehouse, though. The historians head out to take a look. The shopkeeper turns to you. Any chance you can see why our computers are having issues again? The computers appears to be trying to run a program, but its memory is corrupted. All the instructions have been jumbled up. Goal of the program is to just multiply some numbers. It does that with the instructions like MUL, where X and Y are 1, 2, 3 digit numbers. For instance, MUL 44, 46 multiplies 44 by 46 to get a result of 2024. Similarly, other examples are there. Because program memory has been corrupted, there are also many invalid characters that should be ignored, even if they look like part of mal instruction sequence, like do nothing. Consider the following section of corrupted memory. Only 4 highlighted sections are real. Adding up the result of each instruction produces 161. Scan the corrupted memory. What do you get if you add up all the results of the multiplications? I have solved the question already. My answer is this. For part 1, we'll soon check the Java code for my solution. Part 2 has an extended statements in the program. 2 new instructions you need to handle. The do instructions enables, don't disables. Only most recent do and don't instruction applies at the beginning. All instructions are enabled. Corrupted memory is similar to the example from before, but this time instructions are disabled because there is a don't instruction before them. The other instructions function normally, including one at the end that gets re-enabled by a do. This time the sum is 48. What do you get if you add up all the results of just the enabled multiplications? I get this answer. Let's check out the solution that I have for this in Java. So my simple solution is to have a regex pattern for first part of the question. Where X and Y are 1, 2, 3 digit numbers. We have to match the pattern I've created for only multiple MUL instructions. Now while we have a match, we keep on extracting X and Y and adding it to our total sum. This would give us the part 1 solution. Part 1 answer. For part 2, I have the regex in this form. If any of the group matches or it's not null, then I again parse out the integers and add the result to my result set. If it's a do or a don't, just add the match. The final result is a list. I have the instructions from my parser. Now for each of these instructions, I'm using the active flag. If it's an integer, I'll add it to the sum. If the instruction has a don't, we reset the flag to false. That means it's not an active instruction. Otherwise, if it's do, then we consider that instruction and make a flag to true again. Final answer for part 2 is the sum that we get after adding all the instructions. Yeah. Let me know or share out your solutions for a better. I think maybe these patterns or each expressions can be created. There can be a better expression or maybe not. I don't know. Share your solutions. I'll be more than happy to know what other thoughts are there out there. So thank you.